Let's learn how to find the equation of a tangent line. So this is related to derivatives. So first of all, what is a tangent line? A tangent line touches your curve at exactly one point. And they're going to tell you in the question, find the tangent line of some function at some x value, or maybe they give you the entire point. But they have to give you the f of x, and they have to give you at least the x value of the point. So the first thing we're going to do is we're going to find the derivative. So in order to find the derivative here, we have a function of x over a function of x. So remember, whenever we have a function of x being divided by a function of x, we're going to be using the quotient rule. You cannot derive just the numerator and derive the denominator. So what does the quotient rule say? U prime v minus v prime u over v squared. Your u is going to be the numerator, your v is your denominator. So for our derivative, the denominator is going to be v squared, which is the denominator squared, so 2x minus 1 squared. And for your numerator, you're going to derive u first. So the derivative of x plus 3 is 1 times your v times 2x minus 1 minus derivative of 2x minus 1, which is 2, times your u, which is x plus 3. And make sure you're putting all the brackets so you do this correctly when you multiply it all out. So now we're just going to open this up, and we're going to get 1 times 2x, which is 2x, minus 1 times 1, which is 1, minus 2x, then minus 6. Over 2x minus 1, all of it squared. My 2x and my minus 2x, my numerator is going to cancel. I'm just going to get minus 7 over 2x minus 1, all of it squared. Now we're done with step 1. We found the derivative. Now we're going to move on to step 2. We are going to find f of x and f prime of x at the value of x that they gave us. So at x equals 1. Because we're trying to find the tangent line at x equals 1. So we need to find f of 1 and f prime of 1. And you're going to see why we're going to need these in step 3. So first of all, to find f of 1, you're just going to take your function f of x and substitute. Instead of x, you're putting 1. You're going to get 1 plus 3 over 2 times 1 minus 1. You're going to get 4. Now for f prime at 1. So you're going to substitute x is 1 inside your f prime, minus 7 over 2x minus 1 squared. You're going to get minus 7 over 2 times 1 minus 1 squared, which is just minus 7. Now we have our f of 1 and we have our f prime of 1. Now we're going to move on to step 3, which is substituting into the equation of a line. And this is going to be my tangent equation. So remember, the point slope equation for a line is y minus y1 equals m times x minus x1, where x1, y1 is a point and m is the slope. So now we just have to figure out from the values that we found what is what. So first thing, the derivative, f prime at 1, that's going to be your slope. So that's going to be your m. So you're going to be substituting minus 7 instead of your m. Now, for your x1, it's going to be the value that they gave you for x. So my x1 in this case is going to be x is 1. So I'm going to be substituting 1 instead of my x1. And for your y1, you're going to be substituting the y value when x is 1. Well, that's exactly f of 1, which we found to be 4. So those are the 3 things that you need. So that's why we needed step 2. Now, sometimes they give you the y value. If they had given you the point with the x value and the y value, then you could have just substituted the y value there, and you in step 2, you would just be finding f prime at 1. You wouldn't have to find f of 1 if it's given to you. So let's go ahead and let's substitute everything. So y minus y1 is 4 equals m. M is minus 7. It was f prime at 1. And then brackets, and then x minus, and then instead of x1, we're substituting 1. And now we're just going to open this up. So we're going to get y minus 4 equals minus 7x, then minus 7 times minus 1 plus 7, and move the minus 4 to the other side. Y equals minus 7x plus 7 plus 4, which is plus 11.